Okay, now we're going to talk about a kind of general form that we often see transformations in. So if we have a function f of x, a general form that we may see a transformation in looks like this. And a whole bunch of stuff has happened to this function f. Okay, so wow, what happened to this function f and how do we make sense of this formula? So you could look at this formula and kind of memorize what this means, but that won't help you very much if you were instead to see something that looked like this, for example. Or if you were to see something that looked like this. So we want you to be able to really see any transformation of a function and make sense of what it means. So while this one is particularly common and useful, especially as we get into trigonometry, we also want you to be able to make sense of other things. So we're going to look at this one and try to understand what has happened to our function graphically and how we can look at this and make sense of it in a way that we could also look at other versions and make sense of what's going on with them. Okay, so let's look at this one in more detail. So the thing that I find easier to understand and most students find easier to understand is what is happening to the outputs. So we have these outputs. Let's ignore our transformations to the inputs for the moment. We have these outputs, and what we see happened is first they were stretched by A, and then K was added. Okay, and this kind of makes sense. It follows our order of operations. First, these outputs were stretched by a factor of A, and then K was added to the outputs. A shift happened. Let's dive a little more deeply into the input of this function, because this is where things are a little more challenging. Okay, so just looking at the inputs now, I'm going to rewrite this so we're just looking at this set of transformations. I know there's some horizontal stretch or compression, and I know there's some horizontal shift, but which one happened first? I could memorize it, but I can also say, let's try it. Let's see which one happened first. So I know there's something happening with a compression by 1 over b, and there's something happening with a shift right by h. So let's actually write these down and examine what happened. So let's try this order, shift right by h, then horizontally compress by factor of 1 over b. So we're going to try that order, and we're going to try the opposite, and we're going to see which one gives me that. Okay, so the opposite order would be horizontally compress by a factor of 1 over b, then shift right by h. Okay, so let's use some different colors here. I think the neon yellowish green is my favorite. So shifting right by h. So I remember that to shift right by h, I need to do f of x minus h. And if we were thinking graphically, if I want all my outputs to move to the right in my new function, when I input those, I need to shift them back to my original inputs, which is why I have to subtract h to graphically shift right. Okay, you can go back to one of the other videos to remember why this is true. Okay, now how do I horizontally compress? And here's where it can be very helpful to name this function something new. So I'm going to name it m of x. And so m of x is a new function defined as f of x minus h. I want to horizontally compress m of x by a factor of 1 over b. So to do that, I'm going to take m of b times x. Now, what is m of b times x? I'm going to remember what this is in terms of f. This is f. B times x is my input, so anywhere I had an x, I now have b times x. This is f of b times x minus h. That's not this here. Okay, so this is f of b times x minus h. Let's do them in the other order and see what we get. Now I want to horizontally compress f of x by a factor of 1 over b first. So that's going to be f of b times x. Again, I'm going to give this a new function name. We're running out of names, but that's okay. Let's call this q of x. And the reason why is this second horizontal transformation is a little bit easier to apply, or it's more clear as you're starting to learn this if I can think that it's replacing this x. So now I want to shift the result q of x right by h. So I want q of x minus h. X minus h is my input. I want to plug that in for x in my function q. So what that is f of b times x minus h. Okay, and again, that's because x minus h, when I shift, x minus h is my new input, and I need to put that in for x. And that's why I have these parentheses here. Okay, so doing these both, what I see is that when I see f of b times the quantity x minus h, what that means is I compressed first by a factor of 1 over b, and then I shifted right. And the order here does matter. Both of these are acting on the inputs, so the order does matter. I see I have two different results depending on which order I did this in. So how could I have seen this right away? Well, I think it really helps to do this kind of work first. And then once you get used to that, you can look at this and notice, okay, when I'm working on the inputs, by doing this, I now have the experience to see that what happened on the most inside, right? I replaced this x with x minus h. What happened in the most inside actually happened last. Okay? And going through this process helps me see, what happened the most inside this b of x happened last. What happened the most inside this x minus h happened last. And so I can kind of unpack it. This happened last, this x minus h, it's the most inside. It was the last substitution made. And so I can start to get used to reading this as this happened last, so this happened first. This horizontal compression by 1 over b happened, then the shift by h happened. Okay, so let's take a concrete function and work with it a little bit and take a concrete transformation. So let's make a function. Let's make one we haven't used yet. That's not too complicated. Okay, I'll take this function. So let's say this is f of x, our original function, and then we're going to apply some transformations to it. Let's take transformations. Let's see what happens. No, I don't want that. Let me erase that. I want to do something different. Now I got a big smudge. That's okay. Let's take f of 2 x plus 1. Okay, and so when I look at this, my big question is, wait, was this a shift left by 1 and then a compression by 1/2, or was that in the other order? So what we saw doing this with general variables b and h is that the inner thing happened last. So what I think has happened here is I think the last thing to happen was a shift left by 1 because that's the most inner thing. And then I think what happened first was a horizontal compression by 1/2. Okay, so that's what I think. Let's do these things graphically and then use some points to check our work. So a horizontal compression by 1/2, I'm going to end up drawing through myself here, is this pink line. And then a shift left by 1 would be this violet line here. Okay, so graphically, I horizontally compressed by 1/2 and shifted left by 1. Let's use points on this violet graph to check that this formula gives me this graphically. Okay, so here's a point on my graph, -1, 1. And I can plug in -1 here to verify that this indeed graphically corresponds to this formula. So let's do that. So let's plug in, we can give this a new name. Let's call it J of X. Let's verify using this point that that this graphically corresponds to that symbolically. So I'm going to plug in -1 to J. That means I need to plug in -1 anywhere I see X. F of 2 times -1 plus 1, which is F of 2 times 0, which is F of 0. My original function F is here in neon green. F of 0 is 1. Ta-da! So what I see is, indeed, I carried out these transformations that I thought were happening. I carried them out graphically and then used this point to check that what I thought was happening did indeed happen. Okay, so if I had looked at this and said, well, actually, if I had gotten the order wrong, so let's take a step back. This is right. I've just verified it. We kind of used our intuition from before that this inner thing happened last. But say I didn't remember that and say that I thought what had happened instead was, say I thought what had happened was a shift left by 1 followed by a horizontal compression by 1/2. What I want to show you is that we can carry this out graphically and that this point check is going to help us find our mistake. Okay, so I'm going to redraw this here so things don't get too crowded. So here's my original graph, f of x. I'm going to shift left by 1. I'll use some different colors here to help us see it. And then finally, a horizontal compression by 1/2 is going to look like this pink graph here. So now let's use, if I thought this is what happened here, so sometimes in this class we're going to give you a formula and ask you to tell us what happened. If this is what I think happened, I'm going to use a point now to check and see that this is wrong. Okay, I'm just going to divide this a little bit here. Okay, so my pink graph, let's take a point on here. Let's take the point. So this was 1. This would be 1/2 0. You probably can't read that. Let me write that bigger. So the point I'm going to use to check my work is 1/2 0. So just as I did plugging in -1, I'm now going to plug in 1/2 to my function j and see what happens. See if I get out 0. So j of 1/2 equals f of 2 times 1/2 plus 1 equals f of 2 times 3/2 equals f of 3. Eee. Something is very wrong here. Can you see what is wrong? My function f isn't even defined at 3. I've given it an input now, which is not even in the domain of f of x. Okay, so this was our original f of x here. So something is wrong. Okay, I have given it something that I can't even compute. And so what this is telling me is that graphically, this could not be what has happened. 1/2 is not something that I can deal with. And this makes sense because when we look at our correct graph here, our correct final graph, we see that 1/2 is not actually in the domain here. And so when we tried plugging in 1/2 here, it makes sense that we get something we can't compute. Okay, so there's 2 morals here I want you to take away from this. One is to remember when working horizontally and combining multiple transformations that the innermost thing happened last, and you kind of work from there to see what happened first. And also that when we're trying to figure out what this corresponds to graphically, we can carry out these transformations and use points to check our work. And this is always helpful because anybody can make mistakes doing this. We always need to combine some amount of memorization, conceptual understanding, and checking our work.